Hi everybody, this is Professor Amber Colasar. I wanted to record a quick video for you about dimensional analysis. I know you learned about dimensional analysis in fundamentals, but we're ramping it up a little bit in adult health. So you've been given the packet in an email, but I wanted to record this video just to go over a math calculation solving for mLs per hour for a micrograms per kilogram per minute dosage. So you're really going to just follow the same process that you did solving for your dosage calculations before. We're just, again, stepping it up a little bit, a few more conversions. So our first practice problem, concentration is 4 milligrams in 250 mLs, and the patient weight is 100 kilos. Our dose is going to be 0.5 micrograms per kilogram per minute. Now, we are solving for mLs per hour, and I want to highlight something. This kilogram per minute is always going to stay together in your dosage calculation dimensional analysis write-up. So it's really important. If you separate the kilo per minute, you will get the answer wrong. So really important as you're doing that. There will be one of these math problems on your math competency at the start of the semester. So let's figure this out. So what we know is that with dimensional analysis, we start where we want to end. So we want to end at mLs per hour. So we start with 250 mLs, and what's in 250 mLs is 4 milligrams. So 4 milligrams, we need micrograms. So 1 milligram is 1,000 micrograms. And it always helps me to just cross everything out as I go along. So 1,000 micrograms, we can get rid of mics using our 0.5 micrograms. And then this is where students mess up, right here. So this kilo minute. Okay, so kilograms per minute, I'm gonna highlight it again just so you remember. Kilograms per minute, mics, cross out. Now, kilos, we have a 100 kilogram patient. And I will often leave this just blank, or I might, if I'm having trouble remembering, I might just put patient in parentheses because we don't really need that. So kilo. So we have mLs per minute. We're not quite where we need to be yet. So 60 minutes in 1 hour, minute. So we have mLs per hour. Now let's do our math. So 250 times 0.5 times 100 times 60 is 750,000. 4,000. 750 divided by 4, 1, 2, 3, equals 187.5 mLs per hour. So that's a lot per hour. All right, so that's one way to solve it. Some people know their conversions pretty well. If you get confused, I would recommend writing it out long ways like I just did, but you could easily do 250 mLs is 4,000 micrograms, and then we need 0.5 micrograms per kilogram per minute. Remember, this is where we mess up. So mics cross out, and then we have a 100 kilo patient, and then minutes, 60 minutes, 1 hour. So you'll get the same answer that way. Okay, so just a little bit of a shorter way, just skipping this one little section. Again, my recommendation is if you tend to, miss your decimal spaces, I would just write it out because you can cross everything out along the way. Now, I want to give you a different example. Sometimes you are going to be given something like this where you have pounds. So the way I have always done it is to just convert pounds to kilos outside of the equation. I just find that it's much easier to do 175 divided by 2.2 equals 79.5 kilos. Okay, that's how I like to do it. Again, I just find it to be a little bit easier, less conversions, less things to cross out. But either way, you could do it. Let's practice it with just the pounds. So we start where we want to end. So our concentration is 50 milligrams and 250 mLs. So 250 mLs, we want to end with mLs, and 50 milligrams. So 1 milligram, 1,000 micrograms. And our dosage is 1.5 micrograms per kilogram per minute. Milligrams, mics. All right, so if I did not convert, I would have to go with pounds. So 1 kilo is 2.2 pounds. Sorry about that. Kilo. And then we have a 175 pound patient. Now we can get rid of pounds. Okay, so we're left with mLs per minute. That's not quite where we want to be yet. So we have 60 minutes and 1 hour. Doing our math, 250 times 1.5 times 175 times 60. Very odd number there. 50 times 2, 3, 35.79, and our pumps only go to tenths, so 35.8 mLs per hour. So again, we could do this just using kilos. Same problem, I'm going to do the exact same problem, just having converted from pounds to kilos outside of the dimensional analysis setup. So 250 mLs, 50 milligrams, 1 milligram is 1,000 micrograms. We have a dose of 1.5 mics per kilogram per minute. Mics, milligram. Kilos, we have 79.5 kilogram patient. Kilo. And then 60 minutes in our 1 hour. Do the math again. Hopefully it comes out the same. 1.5 times 79.5 times 60. 178. Divided by 50. Sorry about that. Divided by 50. 35.775 equals 35.8 mLs. Same answer per hour. Okay. So I do apologize for my little math miscalculation, but you can see that we do get the same answer either way. So you can convert kilos to pounds outside of the calculation, or you can just work like this using pounds within the calculation too. So I hope that has been helpful for you. If you have any more questions, please make sure to consult the math packet, and you can email your professor as well. All right, have a nice